Pythagorean theorem can be used to determine a missing side length of a right triangle. So you can be given two sides and you want to find the third. I want you to notice that sides A and B are both legs of the right triangle, and they can be interchanged because we're adding them. So for instance, if I said what's 4 plus 2, you would say 6, but if I say what's 2 plus 4, it's also 6. So the order we add them doesn't matter. So you don't have to worry about mixing up the A and B that I highlighted there. But the c squared is important. It's called the hypotenuse. The c is the hypotenuse, and it's across from the 90-degree angle. It's the largest side because it's across from the largest angle. So our first example is 6, 4, and x. 6 and 4 are both legs because the hypotenuse is what's missing. So I'm going to do my a squared plus b squared equals c squared. And next I would do my exponents. So 4 squared is 16 plus 6 squared is 36 equals x squared. 52 equals x squared. And you can begin to simplify that. If your calculator doesn't do it for you and you square each side, then you want to use a factor tree. You do not want to write this as a decimal. So 52 is 4 and 13. 4 becomes 2 and 2. So we have a pair of 2's that come outside, and the 13 stays in. So 2 radical 13 is x. For this problem, we have a binomial, so things are a little bit different here. We have this x minus 1 squared plus my other leg, 5 squared, is equal to x squared. So we first need to take care of the binomial. Remember that x minus 1 squared means x minus 1 times x minus 1. Then I'm going to do first, outer, inner, and last. So first, x times x is x squared. Outer, x times negative 1 is negative x. Inner, negative x again. And last is plus 1. So I'm going to combine like terms there. X squared minus 2x plus 1. I'm going to bring down my 5 squared that I haven't used, which is 25, equals x squared. I can combine like terms here. So I get 26 there instead, equals x squared. Get the variables together, so minus x squared from both sides. And the nice thing is that it eliminated to 0, so now I have negative 2x plus 26 equals 0. Since it equaled nothing, it has to equal something. So subtract 26 from both sides and divide by 2. So x equals 13. There's some shortcuts to these right triangles. So for instance, if I have a right triangle, I'm going to tell you this side's 3 and the other one's 4. I already know the third side is going to be 5. But if you didn't know that, you would do 3 squared plus 4 squared equals x squared, or c squared. 9 plus 16 equals x squared. 25 equals x squared. Get rid of the x squared by square rooting both sides. So x is the square root of 25, which is 5. Which is what I told you. So there's something called Pythagorean triples, like 3, 4, 5 triangles. And there's also a 5, 12, 13 triangle. So these are good to memorize because they're time savers. So we use Pythagorean theorem for right triangles. But there's also a Pythagorean inequality theorem. Basically what we're saying is if when we have c squared equal to a squared plus b squared, then I know that that is definitely a right triangle. Sorry, I don't know why this isn't working. Okay, so that's definitely a right triangle. When c squared is equal to a squared plus b squared, that's what the Pythagorean theorem is saying. But when c squared is greater than a squared plus b squared, oh my goodness. When c squared is greater than a squared plus b squared, I know that it's going to be an obtuse triangle. And if c squared is less than a squared plus b squared, then it's going to be an acute triangle. But please notice that the c squared has to come first. C squared always has to come first. This is something that I forgot it today in the lesson as well. But you just want to remember that because it makes this a lot easier. So if I give you an example here, 10, 12, and 15. I know 15 is C because it's greater. The hypotenuse is always the larger side. So that has to be my C. So I'm going to put that first. So 15 squared equals 10 squared plus 12 squared. And I'm going to calculate this. 225 equals 100 plus 144, which is 2. Sorry, I don't want to have equals there, actually. Let me erase that. Wouldn't really matter, but just so you can get a better idea. So does some 225 is in some way compared to 244. So when you were younger, there used to be like little boxes here, and you would have to fill in with an equal sign or a less than or greater than. That's what's happening here. So 225, since it's less than 244, I know that represents an acute triangle. It's definitely not a right triangle. It would have to be equal. So since the c squared was less than the other two added together, it's an acute triangle. Let's do one more. Let's try 9, 14, 17. So again, I'm starting with my c squared, 17, which is 289. 289 is equal to 81 plus 196. I did the equals again. Let me get rid of that. 289 is compared to, in some way, a different color here, 81 plus 196. Well, 81 plus 196 is 277, and I know that 289 is greater than 277, so this is an obtuse triangle.